Okay, hi everyone. Today we'll be looking at the energy topic at GCSE. So this is for those of you doing GCSE higher tier. Now, firstly, we'll be looking at a few different things. So the first thing we'll be looking at is that energy is never created or destroyed. It's only ever transferred from one point to another. So this is the fundamental principle in energy and in physics in general as well. Um, we'll also be looking at work done as well, and what we mean by the term work done. So whenever energy is so we'll be looking at a couple of different types of energy. So first of all, there is thermal energy, or the heat energy that's trapped within an object, and that's related to the temperature of the object. There's also kinetic energy, which is to do with the movement or motion of an object. There's gravitational potential energy, which is an energy that an object has because of its position in a gravitational field. Then you've also got elastic energy, so that's the energy that's held in stretch springs. You've also got chemical energy, which is held in chemical bonds, magnetic energy, which is what holds your magnets to your fridge. You've got electrostatic energy, and lastly, you also have nuclear energy. Okay, so nuclear energy is which is what we get from breaking atoms apart. Now, the key idea is that energy in each of these stores isn't just fixed there. So instead, it's actually transferred in a variety of different ways. So it's transferred mechanically, it's also transferred through heating, it's also transferred electrically, it's transferred through radiation or through light or through sound waves as well. So energy can be transferred through these ways. These are the ways in which energy can be transferred. Now, next we'll have a look at a system. Okay, so a group of objects in a collection or a collection of matter is a system. That's just a fancy word. So when the system changes, energy is transferred either between objects or between different forms of them. This is like an open system. The matter of the system, it can exchange energy with the outside world, which is just all of the matter that's outside of our actual system. And this means that an open system can lose or gain energy as it interacts with the outside world. Now, next, we will have a look at a closed system in comparison. So, a closed system is separate from the outside world, and so neither the matter nor the energy can actually enter or leave. And so, even though energy can be transferred within the system, the overall change is always zero. So there is no overall change. And to understand how this actually works in practice, we can have a look at a couple of examples. So imagine we have a kettle and we fill it with water. And when we turn it on, there's electrical energy from the plug which flows to heat the kettle, where energy is transferred electrically to the thermal energy store as you heat your water up, which basically it means that the flow of electricity warms the metal that's heating the element, and then in turn, this transfers the energy over to the water's thermal energy store. And after a short while, you'll get your boiled water or your hot water kettle. Another way of saying that energy is transferred is through work done. So there's two main types of things that you need to know. So you've got mechanical and electrical. Mechanical work done is when you use a force to move an object, so such as when you kick a ball up in the air, that involves energy from the chemical energy store of your leg to be transferred then to the kinetic energy store of the actual ball. Electrical energy or electrical work is then, therefore, is when the current flows and energy is then required to overcome the resistance of the wires of a circuit. And so, if we put this into practice, we can imagine a train that's about to cross a broken bridge. So, in order for it to stop, it applies the brakes, which create friction between the brakes and the wheels. And then we say that the friction does work as it slows the train down, because it causes energy in the wheel's kinetic energy stores to be then transferred to the thermal energy stores of the surroundings, in the form of heat, which will hopefully slow the train down. Okay, so that is all for today. We looked at a couple of different things. So we firstly looked at the fact that one of the fundamental rules of energy, which is that energy can never be created or destroyed, it's only ever transferred between different forms and objects. We then looked at the different forms of energy or the different energy stores, which is thermal energy, which is the heat energy, gravitational potential energy, elastic energy, magnetic energy, kinetic, nuclear, electrostatic, and chemical. And then lastly, we looked at the ways in which energy can be transferred. So energy can be transferred mechanically, through heating, electrically, and then through light and sound as well. We then looked at an open and closed system, and then we looked at practical examples of this, and also practical examples of when work is done. So hopefully you enjoyed that session. It was quite short, but it's got some of the key information that you need to know. And then to practice this, I would try the questions attached below and see how you get on with them.